Hi, everybody. This is Gagan from Alethea Communications. We are into making test and measurement equipments to test Wi-Fi networks. The reason few of you or some of you would not have heard about us is that we are not very old in the Wi-Fi space. But in the last couple of years, we have made a lot of good progress with the Wi-Fi 6 and Wi-Fi 6E coming in. And with that, today, almost all access point companies and all big operators use us for Wi-Fi validation. Today, the topic for me is to share the learning on a very specific testing, which is VoIP, right? So let me, peep a little bit into the history of VoIP. So how the voice communication in wireless started in around 1990 with GSM, and data came almost a decade later. That is the time I was beginning to work onto the 3G side. At that time, there were different domain for voice, circuit switch, CS domain, and for data, it was PS domain, right? And at the same time, the ideas were coming in that why don't we put the voice also on the packet switch network, right? And some standards started coming in. The primary motivator was the cost effectiveness, that it will be cheaper to put voice over the data because we anyway have packet switch domain working. And Wi-Fi was anyway all about data. So these standards were coming up. I personally worked on integrating H324 in the cellular networks. And another popular standard which came up was SIP, RTP, RTCP. So initial VoIP deployments, they started it around 2004. And by 2008, they gained so much popularity that 80% of the PBX lines that were installed in 2008 were VoIP. Then it started from cost effectiveness, but it's certain, but the ability to co-work with the instant messaging and conference apps made it very, very popular. So being a test and measurement company, we know that it is becoming a very popular thing among our customers. What is the reason behind that is the challenges in ensuring the VoIP reliability. Earlier in circuit switch call, there was a dedicated connection. Now we don't have that, right? So there is a network overload and there is no admission control. When we do a voice call, it just starts going through, right? And then it may face packet loss, jitter, and latency. And I have a audio here which I cannot play. It was the mouth organ that I played to my son. I have been here from past 3 weeks, and it completely got muddled up, right? So such things happen. And though there are a lot of improvements, but still VoIP reliability is an important concern. So I have a summary here from our customers on what they are kind of trying to test in VoIP. So if I have categorized the customers, so if I take OEM, ODMs, they are focused on testing concurrent P2P calls, and they want to make sure that the access point works up to 50 calls, right? And if we come to operators, they want to ensure that the VoIP works while roaming. Their major worry is that if a user moves from one access point to another access point and in between loses quality of voice, then she might just shift to the cellular networks, which is a more cost for the operators. Then in transport segment, where it can be charter planes or ships, the focus is because their backhaul is satellite link, which adds to latency, which is very bad for voice. So the focus is to test over the satellite link and via VPNs. In the enterprise here is offices or classrooms. There the focus is to test on the conference calls when there are multiple APs and there are people in the conference call with multiple APs. So this is what the requirements we are getting from all the customers. So no wonder, that reliability is still an issue, and that is why there is so much of interest in testing VoIP. So test strategy. Test strategy for here is like I think we saw in a lot of other presentations before also. It's not like we just take and debug it and it will work. The strategy is to measure it and improve and keep on repeating the cycle. So now the question comes is what to measure in a VoIP call. So there are two major parameters. One is the call success ratio. It means that when I make a call, user should get it and it should not drop in between. The second is the difficult one is the quality. So how it is measured is that receivers rate the calls from 1 to 5, and then we take average over lot of calls and take a mean opinion score. It is called mean opinion score. It rates from 1 to 5. And this is the way you can measure the quality of voice. And after measuring, what our customers do to improve is that they want to identify that it is a VoIP traffic, then prioritize that it is the VoIP traffic, and then optimize the network parameters. So now next question comes is, how will we test it? Because it is complex. There are people involved in measuring the quality. So let me first tell the data that should go. First, let me show the data, and then I will come to the test setup. So if I show the data, so we did a study with 3 comparable access points, which are equivalent in terms of throughput and equivalent in terms of all the firepower. But when we run VoIP on them, we see that the AP3, which is orange here, the call success ratio goes down as the scale of concurrent call increases. And AP2, which is red, we can see that the call success ratio is good, but the call quality goes down as the number of concurrent call increases. So whatever test setup we have should be able to cater to scale, and it should be able to run the real VoIP applications. We cannot run throughput and say it is okay, right? Next, we also tried with different devices, and there is a difference in behavior with different devices. So in this particular example, we took mix of laptops from Linux and Windows and Mac, and Android devices, different makes of Android devices. And we see as the number of calls increase, concurrent calls, Android stands better than the desktop. So there can be many reasons behind it, but the point that I want to take from here is that there has to be some fine tuning for the devices. That is what our customers are asking us. So we came up with this, it's a bit old slide. We came up with this thing to test VoIP in 2017, where we had a huge hall, and we kept different kind of devices, and we have engineers who will make the call and listen the call and rate them, from 1 to 5, and we used to calculate the mean opinion score. So this results were good, but it had a problem. The problem was it doesn't fulfill our test strategy. Test strategy means that we have to repeat. We have to test. People want to make a tweak and test it in another 15 minutes, right? So that was not possible in this kind of test setup. So then we started studying how to calculate this MOS score objectively. And to our luck, there were specifications coming out at the same time, and ITU specs were there, which kind of specified what all goes in the perception of the voice from when someone is rating it. And based on that, there were models where you give packet loss, jitter, and latency to the model, and then there are some factors in the model, scaling factors, and you get a MOS out. So we played with these parameters and tweaked them, and we found a very high correlation with whatever data we were getting from the manual quality scores. So we implemented this model, and we also implemented automation of getting these parameters. So now our setup, we basically implemented this in our product, and now the setup looks like this, where we have one set of emulated clients which can give you scale. We can have up to 300, it can go to 1,000, we can add multiple of this, and which can give us scale. Then we had another real client where we had full control and sniffer, so that we can really debug what is going on. And then we had commercial clients for all the 5 popular operating systems, Android, iOS, Windows, Linux, and Mac, where we can fine-tune the fine-tune the load. This led to the fulfillment of the strategy where customers could now run it, tweak something, run it again, tweak something and run it again, and could improve it. It was scalable, and it saved a lot of time. And here I have an example of a customer, which is AP4. Here the test setup is 100 clients, while 75 clients are doing video streaming and iPerf. 24 clients are doing 12 VoIP calls. And this AP4, we can see improved in the success rate of 9 to 12 with a very high MOS of 4.37. So they were not there like that. They had to go through these iterations, and then this improvement came. And what the techniques typically people follow are deep packet inspection for identification of the VoIP traffic, and AIML techniques. And for prioritization, it is WMM class and DSCP. WMM class is a little tricky because on the uplink side, applications don't do it properly. So it's a tweaking process that leads to this better results. Now, so this was all from the perspective of ODM OEMs. Next, we are studying right now while doing roaming. And hopefully, if we get interesting stats, I will be there in the next WLPC presenting those insights. Thank you all.